Let us now discuss the refraction through a concave refracting surface, and we are going to consider the first case, that is when light is traveling from rarer to denser medium. Okay, so let me draw the diagram. Okay, so in this diagram, as you can see, we have this concave refracting surface XPY. It is a denser medium having refractive index mu2. Now this concave refracting surface is placed in a rarer medium having refractive index mu1. This line here is the principal axis which passes through the center of the concave refracting surface, where this point out here is the pole. O is the point object. Now the blue color point object, the rays from there will go, it will travel in this direction, it will incident on the surface and strike the surface at point A. So therefore this line OA is the incident ray. C here is the center of this concave surface. So we join C to point A, that would be the radius. Yes or no? And we know that the radius is always making an angle 90 degree with the circumference. So that means that this line AC is normal to the circumference. So if we extend this, the line AN will become the normal. Got it? So basically the line CN is the normal. So you have the incident ray OA, the line CN as the normal, angle between them is the angle of incidence I. Alright. So this ray of light is going like this in the rarer medium and it is entering the denser medium. So we know that whenever light goes into the denser medium from rarer, when it travels from rarer to denser medium, it bends towards the normal, right? So let me show you how. If you look at this direction of the ray of light, okay, if you look at the direction of the incident ray, you see this incident ray, this is the direction of the incident ray. But because it is entering the denser medium, it bends towards the normal. So that is why it takes this direction. It bends like this. Instead of going this way, it bends towards the normal. Got it? Now another ray of light will be going along the principal axis. Okay, so if you produce this ray of light along the principal axis and this refracted ray, they will never meet. Okay, because they are going away and away from each other. Let me extend this another ray color, a ray of light going in that direction. Okay, so if you look at this ray and that ray, they will never meet because this is a diverging lens. Got it? The two rays, they go away from each other. So what we do is we trace the ray backward. So if we trace the ray backward, they seem to be meeting at this point I. So this is the image which is formed out here, and it is a virtual image. Got it? So this ray out here, this is the refracted ray, and the angle between the refracted ray and the normal, this small angle out here, this is the angle of refraction. Okay, now from the figure it is very clear that this angle and this angle are the same. So this also will be the angle of refraction. From point A we drop a perpendicular onto the principal axis. Alright, and we name these angles as alpha, beta, gamma. The distance from C to P, that is radius of curvature, from the image to the pole, that is the image distance, and from the object to the pole, that is the object distance U. Okay, all right, so now we are going to apply the Snell's law. So by Snell's law, look at the diagram. I is together with mu1, so you have mu1 sine I will be equal to mu2 sine R. Okay, and we know that I and R are small angles, so sine I will be approximated to I itself. Similarly, sine r. So instead of sine I, we will just write I, and instead of sine r, we will just write r. Call this sum equation 1. Now we want to find the expression for I and r. Okay, look at this triangle out here. Which triangle? AOC. If you look at this triangle AOC, you see that I is here, alpha is here, and gamma is the external angle. So this will so gamma here will be equal to the sum of the opposite internal angles. So gamma is equal to I plus alpha. Which triangle? AOC. In triangle AOC, gamma is equal to I plus alpha. Gamma I plus alpha. So this implies I to be gamma minus alpha. Equation 2. How do we find R? R is inside this triangle, this one. Which triangle? AIC. AIC. In triangle AIC, what do we have? Again, gamma is the external, R and beta are the internal angles. So you have gamma is equal to R plus beta. So from here you have R is equal to gamma minus beta. Call this sum equation 3. Let us put 2 and 3 in 1. Putting 2 and 3 in equation 1, we get mu 1 instead of I, you write gamma minus alpha is equal to mu 2 instead of R, gamma minus beta. Now what we do is we replace these angles alpha, beta, gamma by their tangents. So you have tan gamma minus tan alpha is equal to mu 2 tan gamma minus tan beta. Okay. All right, now look at the diagram once again. What is tan gamma? Tan gamma, this angle here, tan gamma would be perpendicular by base. That means AM by CM. AM by CM minus tan alpha. Alpha is here, AM by MO. AM by OM. Okay, so again tan gamma here will be AM by CM minus tan beta. Beta is here, AM by IM. AM by IM. All right, let me draw one line out here. Okay. Now I'm going to cancel the AMs and I'm going to put the mu1 and mu2 inside of the bracket. You have mu1 by CM minus mu1 by OM is equal to mu2 by CM minus mu2 by IM. Okay, call this sum equation 4. But what is CM? CM, if you look at the diagram here, CM is nearly equal to CP. Okay, this is nearly equal to CP. And what is CP? CP is nothing but minus R. Right? I think you know why minus. OM here is nearly equal to OP. That's nearly equal to OP, and what is the value of OP? OP here is minus U. Minus U. What is IM? IM here is nearly equal to IP, and that is minus V. Let us look. IM from I to M is nearly equal to from I to P, and that is minus V. Yes, so these distances are all negative. Why? Because they all lie on the left side of the pole. Got it? So let us switch these values in equation 4. So you get mu1 by CM, which is minus R, minus mu1 by OM, which is minus U, is equal to mu2 by cm. Again here this is minus r minus mu2 by im, which is minus v. Okay, so I'm going to take this to the other side. Wait, let me do one thing. Let me write one more line out here. Mu1 by minus r, this will be plus mu1 by u is equal to mu2 by minus r plus mu2 by v. Okay, so let me take this to the other side and this here. So I will get mu2 by r minus mu1 by r is equal to mu2 by v minus mu1 by u. Okay, so I get mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. This is the required expression. Thank you.